Hi everyone. I've got problem 10-5 on the screen. Let's work this one together to illustrate a few capital budgeting methods. This is a pretty good problem to take a look at. Okay, Project S has a cost of $10,000 and it's expected to produce the benefits of $3,000 per year for 5 years, while Project L will cost $25,000 and it's expected to produce cash flows of $7,400 for 5 years. And we're asked to calculate the NPV, the IRR, the MIRR, and the profitability index, or PI, assuming that the company has a cost of capital of 12%. And then we're asked which project would be selected, assuming they are mutually exclusive using the ranking methods. Okay, I've put the cash flows in front of you, and you can see I've got the outflows appearing at right here on row 10, and then I've listed the positive cash flows and the cost of capital. Now I've worked this ahead of time just to save some time, so let's bring it to light and I'll show you what I've done here. Oh, that's not what I want to do. Let's put this one back to what it was. Turn this to black. Okay, we've got 814. Oh, this should be none. Okay. The net present value of this is 814. Let me hit the F2 and I'll show you what I did. We use the NPV formula where we give it the cost of capital as the first parameter, and then we put in the range. Okay, so C11 plus C14, and then we add in the outflow. Now, let me actually redo this one for you before your very eyes. So if I do equal NPV, I'll hit my F2 and bring this down so you can see this. Okay, the rate comes from that cell. And then we give it the range. Now pay attention to what range I'm giving it here. Only the positive flows that occur at the end of period 1. Okay, that gives us the first net present value, but then we need to add to it the outflow or subtract the outflow. I'm actually adding a negative number, but you could simply subtract a positive number. And the reason why you don't include that initial outflow in there is the NPV formula assumes that the range occurs at the end of the first period. In this case, that 10,000 outflow is assumed to occur right now, so there's no present value involved. We simply have to subtract that cost, or another way of saying that is the present value of $10,000 spent today is $10,000. Okay, so that's the 814, and we can just copy that whole formula into Project L. Now with IRR, the formula, I'll just hit the F2, you give it the entire range of all the cash flows, and then you give it a guess. And I always give it the guess of whatever I think a reasonable cost of capital is. In this problem, they gave us the cost of capital, so I just plug it in. Okay, copy that over. We get 15.2 and 14.7. Now Excel gives us a modified internal rate of return, so we don't have to quite go through the formulas the way our textbook presents it. Let me hit the F2 and show you. Here you give it the range, and then you give it the investment capital and a reinvestment capital. Let's delete that and work it from scratch. So I'll go equal MIRR, left paren. Now I'll bring up the formula bar. So we give it the values, and much like the internal rate of return, we give it all of the values, even starting with the value right now, because it's going to compute an internal rate from these cash flows. Okay, then we give it the financing rate. Well, it's 12%. In fact, with modified internal rate of return, both the financing rate and investing rate must be the same. Excel gives us the ability, though, to use a separate financing rate from a separate reinvestment rate. So that's pretty useful. But that's not how our textbook wants to illustrate how to do this. Hit OK, and we get the modified rate of return. I put a negative in there by mistake. Okay, 13.8 and 13.5. I'm just taking this to one decimal place. Then we do the profitability index. Let's bring that to light. Now with the profitability index, let me hit my F2. What we use, or the way I've done it, is I use the NPV formula. as the numerator. You take the present value of the inflows and divide it by the cost of the project. Okay, now you could have used present value. That would have worked as well, but I'm just very familiar with the net present value function, and I ignore the outflows in this example to come up with net present value in the numerator, and then the cost, and I'm making it negative because I've entered it as a negative. The profitability index is expecting that outflow as a positive number, so we subtract C10 from it to come up with 1.8, and we copy it there, and we get 1.07 for problem L. So there we've illustrated NPV, IRR, MIRR, and PIR. Okay, what can we say about the rankings now? Okay, in terms of NPV, if these are mutually exclusive, that means we can only take on one project and not both. L is the greater number, so let me just sort of bold this. That would be the one that would be chosen. IRR 15.2, 14.7. What we see is the IRR of project S is our highest choice. With the MIRR, the highest project is project S. And with the profitability index, again, project S is the winner. Okay, now which of these is the best measure to use? Our book will point out that NPV is the superior method to use when faced with a capital budgeting decision. Okay, thank you everyone.